For centuries, humans looked at the night sky and believed we understood the universe. Planets orbit stars. Galaxies drift through space. Everything follows the laws of physics. Predictable, logical, explainable. But modern astronomy has discovered something unsettling. The more we observe the cosmos, the less it makes sense. There are objects that move in impossible ways, signals that should not exist, and structures so massive they challenge our understanding of reality itself. Some scientists openly discuss these mysteries. Others avoid them. Because if even one of these theories is true, then the universe is far stranger and far more frightening than we ever imagined. Tonight, we are going to explore 10 space theories that scientists rarely talk about. Today, we finally have a reliable size estimate for the interstellar visitor known as 3I/ATLS, and this discovery is telling us much more about our solar system than most people realize. Astronomers analyzed a large collection of Hubble Space Telescope images taken from November 2025 through January 2026. After carefully studying the brightness and reflectivity of the object, scientists calculated that 3I/ATLS has a radius of about 1.3 kilometers with a small margin of error. That means its diameter is roughly 2.6 kilometers, less than 2 miles across. Although earlier predictions suggested it could be tens of kilometers wide, those estimates were exaggerated. The object is closer in size to a typical comet from our own solar system. Still, it is larger and more massive than the previous interstellar visitors, Oumuamua and Borisov. This strongly suggests that 3I/ATLS is a fragment of a planet-forming body, a planetesimal, that was ejected from another star system long ago and eventually wandered into ours. Astronomers also created a motion sequence by stacking multiple telescope images taken between January 15th and January 18th. The object appears to move across the star background because the tracking software kept 3I/ATLS centered in the frame. Interestingly, the object does not show a typical sun-pointing comet tail. Instead, observations indicate a tail aligned opposite its direction of motion, meaning dust and particles are being pushed away behind it as it travels. Plasma interactions and electromagnetic effects in space may also play a role. Now that scientists know its size and reflectivity, an albedo near 0.04, they can estimate how common interstellar objects are in our solar system. Here is the surprising part. We have only confirmed 3 interstellar visitors: Oumuamua, 2017, Borisov, 2019, and 3I/ATLS, 2025/26. But modern sky surveys constantly photograph the sky and track faint moving objects far dimmer than the human eye can see. So if telescopes have been watching the sky for years, why have we detected so few? The answer is likely simple. We have probably missed many of them. Using orbital modeling, researchers estimate that within about 4.5 astronomical units of the Sun, roughly the distance approaching Jupiter, there may be one interstellar object passing through every year. Before we continue, if even one of these theories turns out to be true, our understanding of reality would completely collapse, and the next one might be the strangest of them all. Right now, 3I/ATLS is traveling between Mars and Jupiter inside the asteroid belt. Jupiter orbits the Sun at about 5.2 astronomical units, and the object will make its closest approach around March 17th before continuing outward forever. Unlike planets and comets bound to the Sun, interstellar objects follow a hyperbolic trajectory. They enter once, are slightly deflected by gravity, and then permanently leave the solar system. This also explains something important. The lack of detections in the past does not mean these objects were absent. It simply means our instruments were not sensitive enough or were not looking in the right place at the right time. Beyond Neptune lies the Kuiper Belt, a vast three-dimensional region extending far above and below the plane of the planets. Interstellar objects can enter from any direction, not just along the planetary plane, making them extremely difficult to detect. If one object is expected near Jupiter every year, then across the entire outer solar system there could be many of them present right now without our knowledge. As newer observatories and sky survey programs come online, astronomers expect the discovery rate to increase dramatically. We may soon identify these objects regularly and analyze their chemical composition and origin. The major takeaway is this: interstellar visitors are not just a rare anomaly. It is evidence that our solar system is constantly interacting with material from other star systems. For billions of years, interstellar debris has likely been passing through our cosmic neighborhood, occasionally influencing planetary environments and possibly even delivering organic material. Humanity is only now beginning to notice. The universe is not isolated star systems separated by empty space. It is a dynamic environment where stars exchange material across enormous distances. And as detection technology improves, we may soon discover that interstellar visitors are not unusual at all. They are a normal part of living inside a galaxy. I'll continue updating you as 3I/ATLS moves past Jupiter and exits our solar system. But the real story may be much bigger. We may have been surrounded by interstellar objects for thousands, even millions of years. We are just now becoming aware of it. The universe has always been a place of wonder. But sometimes wonder turns into unease. Because the scariest part isn't that we don't know everything about space. It's that we might already be seeing clues and we don't understand what they mean. If you enjoyed this journey into the unknown, make sure to subscribe, because the next discovery could change everything we believe about reality. And trust me, we are only just beginning.